All right, we're going to try the fifth root now. Again, more difficult, right? Let me pull this up. And we want the fifth root of, what, 240, I'm sorry, 223, right? So the fifth root of 223. Certainly getting more difficult, but you know I'm looking for those integers again. So the fifth root, and we're looking for perfect fifth powers. So like 2 to the fifth power, that's going to be about 32, right? And 3 to the fifth power, well, that's going to be, let's see, 81 times 3, so 243. All right? So let me write this down for you. 3 to the fifth, and this would be 2 to the fifth. So this number here is going to be between 2 and 3. Now, certainly, I know it's closer to the 3 than it is to 2, just looking at that. All right, so I'm going to say the fifth root of 223 is going to be closer to 3. I'm going to say, roughly about 2.9. All right? Your goal, though, is to write it down as an equality using those numbers. 223, it's going to be the fifth root. Well, 2 to the fifth is 32, right? Plus, 223, let me write this over here, minus 32, that's going to be 1. And then we get 191. And that's true, it's true. And fifth root of 3 to the fifth power is 243, right? Minus 20, right? That's not bad. Let's write this down. And again, this is equal. There's no doubt about it's equal. Unless I made a stupid mistake with the arithmetic, but I hope I didn't. I could say 32, 1 plus 191 over 32. And by the way, it's still true. But I can't use the binomial theorem on it. And the reason for that is this is not a proper fraction. It's just not going to converge. So let's look at the other one. That's going to be 243. And that's going to be 1 minus 20 over 243. We're good to go. It's a proper fraction. So that's what we're going to do. So let's write this down. The fifth root of 223 would be equal to, the fifth root of 243 is 3. And then I got this over here, which is going to be 1 minus 20 over 243 to the 1/5 power. All right? Still all true. It's all equal. Now what we're going to do is we're going to use the binomial expansion for it. And it's like I always say, that the first two terms are really easy to write down. It's going to be 1 plus 1/5 times minus 20 over 243. Those two really, it's almost like a dead giveaway. Then you got to write the other ones down. And that's why I wrote the stuff down for you. If you look in the notes on the examples, I wrote the expansions down for you. Right, expansions that we've derived before. I'm not going to say they're easy to derive, but they are derivable, by the way. It's the numbers that are hard to compute with. So what do you get over here? 2 over 25, and then you get minus 20 over 243. And yes, you're allowed to use calculators. Plus 6 over 125. You can just see how bad this is getting as far as a computational skill. 243 cubed minus 21 over 625 minus 20 over 243. 1, 2, 3. We're at 4 now, right? Wow, it keeps going and going and going, and this never, ever, ever stops. 399 over 15,625, and that's minus 20 over 243 to the 5th power, yada, yada, yada. It goes on forever, right? We don't have time to go on forever. So what we'd like you to do on your calculators, take the 5th root of 223, and that's going to be approximately equal to 2.95. By the way, your calculator can do a lot more digits. Do as many digits as you like on your calculator. And what I'm going to encourage you over here is also do this computation. Kind of carry it out. And you're going to find out remarkably close they are, all right? Now, you're going to hit a digit where they're going to disagree, and the reason for that is we're not continuing forever. We're not continuing forever. But you get to a good precision, and you could just imagine how useful this was in computing roots, all right? What's the problem with it? It's the computation again. It's difficult. No one sees this as being easy, by the way. With a digital computer, though, it becomes much easier. I mean, really easy. Thank you.